very high chance that when technology is locked and in hands of like few people, even if it's board of OpenAI or it's like Facebook or like Meta or whoever, we are in danger.
Yeah, and it's interesting because on this podcast, I mean, like one of the reasons we started it was to demystify AI, and the underlying idea of why this is so important to demystify AI is that me and Anders has used the word, and we have stolen it or framed it, what we refer to as the AI divide. You have heard about the digital divide, but we think it's much more important to understand the AI divide. And of course, on a geopolitical scale, we all see the problems when an extreme amount of power in terms of wealth is with a few. So I think this is hardcore down to one of the key themes why we do this pod is to think about how do we fight the AI divide and what does that mean. And I used to put another flavor on this. We had Erich Hugo, who is working with Delta Track, like a Silicon Valley company. His background is South African. Now he also highlighted the AI divide, but he went the other way around. We have talked a lot about the super powers or the really AI savvy towards the rest of Europe. But coming from South Africa, he put the light on the other end of the scale of the AI divide, which is ultimately, we can talk about AI apartheid. And it's really scary because we are pushing now even Swedish company pressure on farmers in Africa or India to have, things or have 5G, where they can't, when the whole country is running on 2G. And, think about what happens now when you put ChatGPT in the mix and it's a $20 per month approach to even be part of the game. Mm-hmm. And so he's sort of proponing a lot around these topics of AI divide. We need to really look at both ends of the scale, and we need to think about this carefully. Do you follow? Do you agree with this topic of the AI divide is massive?
Yes, I mean for me, like the main problem about this is like when I'm thinking about it, I become very emotional. Yeah. So and then it's like sometimes it brings me like bad emotions, I would say. So sometimes, like I prefer, like in this especially current political climate, I prefer to say, okay, that's maybe enough. I will focus on renewable energy for now.
One huge problem at a time.
Yeah, but I mean, like it's like it's like so much connected. So like I mean, I don't want to go like into like political even things, but like for me coming from Belarus, like everything that happens now in Eastern Europe is the big thing, and then the like AI and problem it brings and powers like other countries have. It's I think my parents already lived in some country like this where I don't want to live at all.
Yeah, and what about you, Jonatan? What is your take on this? Because we started the conversation with the Sam Altman. The entry point to this conversation. Tell us about this. It was the Sam Altman part 2 episode with Lex Friedman.
Yeah, no, I was just reflecting on Lex asking him, well, what if you have too much power? How can we trust you with that much power? And he said, well, you can always fire me. And then he caught himself saying, well, I actually got fired, and that didn't work. No, I think the perspective I have is I'm a bit scared, but I think we tend to go through these cycles over and over again, like the same with the internet, also a big divide, like wealth and so on. And I think I can't conceive of a structure where people don't end up with too much power.
Yeah, but and then of course this might be the segue into introducing you and all that. It's like on the one hand side we have all these challenges. On the other side we have other types of challenges like CO2, like optimizing the grid, like we have a flexibility problem. We don't have a capacity problem, so to speak. And this is data and analytics and AI that can solve a lot of stuff. And I think that also brings us into we can't put our heads in the sand in this. We need to persevere, is my opinion on this. We need to watch these stuff and most importantly maybe getting more and more on board like the real counterbalance is that everybody else catches up. I think that's the smartest way to do it. But that kind of leads me into segue into, from the AI divide into, this podcast where we're actually going to talk about help me out with the theme, the future of power grids and AI in power grids. Is that a good...
it's a big topic.
It's a big topic, right? Because you can actually talk about the divide in the world of who has stable energy in the future and not. So there's another type of, it's an interlinked divide in this somewhere. And you can also argue if you don't have the right power grids, you're not going to be able to have the right AI and vice versa.
Exactly.
Yeah. Anyway, so that's the theme. And with that theme, I want to welcome Jonatan Raber and Kiryl Zhdanovich. And
pretty
he was
good.
happy because that was a pretty good, decent butchering, but not too bad.
It usually takes 5-6 tries.
I saw that you were approving on my... that's okay. And you guys coming from Fever, and it's a startup, and we're going to talk all about it. But before we get sort of jumping into and we're going to come back to the big topics. I love it. And see if we can connect the different divides, right?
Yes.
Wouldn't that be cool to think about how they interlate?
Absolutely.
Yeah. But I want to start with you, Jonatan. Why don't you, give us, the short background into who you are, and sort of how you ended up working at Fever, or sort of what's your story into where you are today?
Sure. So I guess the nearest history to Fever was actually at Spotify. So I spent a bit more than 8 years at Spotify, actually where I met Kiryl.
Yeah, this is where you were colleagues, and I guess you were also colleagues to Anders, that hopefully joins later.
Not sure if it's important clarification. I was at Spotify 2 times. Once as the employee, another time as a consultant.
Ooh.
First time I met Anders. The second time I met Jonatan.
Ah, no, I didn't know that. Cool, nice. All right, continue, Jonatan.
No, I was there for 8 years, working on many different things. I started out on the business strategy side, and then moved over into product development.
Which parts? I'm just curious.
On growth, actually. So I focused a lot on how to grow our subscriber base, on our overall user base, how to increase activation, how to increase engagement. And within that, I focused a lot on the first moments of coming to Spotify.
The whole experience where you get them in.
Exactly. So you have a massive amount of people downloading the Spotify app, opening up the Spotify app. And my job was to take it from that moment into an active session and into a retained user. And it was really interesting because we started thinking about how we could use machine learning in this environment. And obviously Spotify focuses a lot on how to understand taste. So the taste onboarding moment, choosing different songs, choosing different podcasts.
Because this is when you're the newbie to Spotify and you start bringing your personalized experience together the first time, where you don't know how it works.
Yeah. So Spotify knows that if a new user has a great first experience, listens to a song that they love, that is a very good indicator if they will come back.
Yeah. So actually, how you manage to tailor that experience to what they are, to blow their expectations out of the water.
Yes.
That is a very strong moment of building long-term good feelings.
Yes. And all this needs to be done in an environment where you have very little data about the user.
At this point in time, this is before you have the data.
Yes.
How do you solve that?
It's very tough. So we did a lot of experimentation, even in terms of how to sign somebody up, the authentication moment. And so you kind of have to guess, using some of the information you have, where in the world are they? What type of phone are they on? Do we have any other kind of metadata or context around that? Even what time of day it is, or what time of year could matter. And then it comes down to actually asking some smart questions. So we thought a lot about how to reduce friction, but also add friction where it was valuable.
So it reduced friction in terms of making less click setup, but actually adding friction by asking maybe some critical questions that can can amplify the experience, I guess.
Exactly. And I'll give you one example, which is in kind of the sign-up flow. Spotify asked a lot of questions that seem pretty strange. How old are you? Why do you need to answer that question when you want to listen to music? So there's some kind of licensing reasons behind that, but actually that information is great when recommending songs to somebody. Because it's very likely that if we recommend, or Spotify recommends a song that you may have listened to when you were 20-ish years old, you like that song.
So this is where that's why we have psychologists and all kinds of people in Spotify in order to build a brilliant product team.
Exactly.
Yeah. And moving a little bit over to you, Kiryl, what's your background? Or you tell us about 2 stints in Spotify.
Yes, I'm originally from Belarus. And after I finished university, I wanted to live somewhere else. And luckily for me, Spotify invited me to live in Sweden and to work at Spotify. And
how do you pull that off? Did you have the best grades ever, or what?
Actually, no. I was very bad at studying in my university because, I thought we will do coding, and then we did some math. Why didn't we do math? Like when was the last time you did math?
You wanted to code hardcore.
Yes, and then I also wanted to party, I guess. So this was kind of like...
Party and coding.
Maybe more party, I would say, to be honest. So I wasn't amazing, but in school, though, I participated in math and physics competition.
Yeah.
And then around 20 years, I was like, okay, actually, I need to do something in life. And then actually I started to study on my own and entered some additional education and start working. And then I was participating in competitive coding competitions. At this time, there is still a platform called Top Coder. So
Top-Coder,
you have limited amount of time. You need to solve problem and then submit it. And then
was it Wipro that bought Top Coder?
Top Coder. So
yeah.
And then there was
yeah. But Top Coder was a little bit this is a platform where you could, NASA could supply a problem.
Yes.
And someone could basically, you bid for, I can solve this problem.
You
and
told me about a problem that NASA...
Yes.
You were working on one of the NASA problems.
So there are different types of competition. Actually, you can do their even design. So, and then there was NASA competition about how do you position solar panel on a space station to get most amount of energy. And then you submit heuristics, and then it was you get one of the best solutions in the world and pay for this $5,000.
Yeah.
And there was algorithm competition.
Oh.
I would say what was quite average there, but I think it's kind of the thing that I liked about coding and algorithm.
Yeah, but Top Coder is cool because if you're super, super good and you can solve the problem fast, you make good money. If you're a hack, you can spend hours on hours and then your hourly rate is not that great.
I think there it was more if you're good, you're being pulled out of Eastern Europe and you will go to work at Facebook or Google.
But tell us how did the Spotify find you, or how did you find Spotify?
I was quite lucky because the story is following. My brother's friend was interviewing at Spotify.
Yeah.
His experience wasn't amazing, and he said, okay, why should I change Google in Switzerland and go to some company in Sweden? Especially if you consider salaries in Google Zurich. And then a recruiter asked, do you know someone else? And then he showed me. And then fun part about interviewing at Spotify was that the maybe 66% of interviews were competitive programming questions.
So this was actually up your alley.
Exactly. So I saw there.
This is what your Top Coder life taught you.
I finished interviews in 15 minutes. And then I had an interviewer who said okay, it's out of the list, but I'm just curious if you can solve this. So and then we spent time like this. And then I went to a hotel room after interview, and when I got internet access, I saw email saying, okay, we want to hire you.
Boom.
And I was okay, I should probably move to Sweden. I had no knowledge about Sweden, had no knowledge about Spotify, because why would you pay for music? So this is nonsense. Why? Who on earth pays? But if you have money and you're inviting me, I'm coming. So that actually what happened. I ended up at Spotify. At this time, I was working with my former brother colleagues who were hardcore C++ developers who were doing offline maps. Yeah. And I'm coming from the culture where if you allocate memory in a slightly wrong way, you are punished in a code review. And then you consider your life choices.
This is hardcore stuff. I love it.
If it was a good choice to start writing C++ in this company, learned a lot, came to Spotify, completely different culture, different people. I was very lucky to end up in 100% Swedish team. They Swedishanize me as much as possible, and I was pretty happy about this. That this was kind of like culture lesson to me.
The cultural lesson, the Swedish culture appealed to you.
Yes.
The way they handle, and what is Swedish culture then in terms of teams and how work life is? Because I think it's very different to Anglo-Saxon culture.
Absolutely. And then just if someone wants to watch about this, I think there is a video on internet called Swedishness that describes it much as possible. So, and then I joke with our CTO Victor that he's like 100% from this video. So it's more like, let's listen to everyone's opinion. And if you're coming from Belarus, you're like, yeah, I'm sorry, your opinion doesn't count here.
So this is, and some people who doesn't know this, we're talking about consensus decision making, deeply ingrained in our DNA, I guess.
Yes. Yes, absolutely. And then my product owner at this time, I was working late, and I sent email quite late in the evening, and then he told me on next day, say, okay, thank you for finishing work. It was important. You shouldn't have done it. So today, go home after lunch. And I'm like, what's happening here? What is like?
You get punished for working late.
And then during the summer, I was like the last one, and he also told me, it's summer in Sweden. You should be out as much as possible because soon
it's going to be dark.
Exactly. And I'm like, what? Okay, sure. You're a smart person. I will trust this. So this was my kind of like lesson at Spotify. Unfortunately,
super nice, super cool.
Unfortunately, I didn't get to work on things I wanted to work.
Yeah.
And I was like a little bit, but I also was quite young and naive. So I wanted, to write the best, most complex algorithm in the world that probably no one needs. And once it also, I implemented some feature, linked a Wikipedia page with the algorithm name that people in the future, and then it was like amazing time complexity. And then my colleagues say, yeah, great, but we have so much, we don't have so much data that it's actually efficient enough. So you could solve it with the simple things which help readability. And I was like, yeah, it's not the thing I was looking for. I was looking for overcomplicate things, show off my knowledge, and then that's why I thought you were asking algorithm questions during competition or during interviews.
Have you changed your mindset on this?
Absolutely. Absolutely.
I can answer that.
Were your bosses right?
In a way, absolutely.
But you were young and you wanted to kick ass.
Absolutely. But then I was like, I had the single tool in my toolbox was my algorithm knowledge, and then I wanted to use them everywhere. I jumped a few teams at Spotify. At the same time, I was finishing some school of data analysis, where I learned a lot from amazing people, how things work in data science and machine learning at this time. And I got another toolbox which I wanted to use. So, and I ended up in search team at Spotify with quite amazing people, to be honest. And then
Anders Nyman, was he coming later in the search team? He was engineering manager in the 2020s.
I left Spotify 2018.
Okay, this is.
So yes, and I was youngish, unexperienced in a way. So I got experience there, but worked there for some time. Then I left. Then I was doing one-person consultancy for around 4 or 5 years in different machine learning products or companies, doing mostly speech recognition. But it's also more like you're selling yourself as machine learning engineer because everyone it's already this hype train is quite old. So fear of missing out, you sell yourself a machine learning engineer, but then you come doing backend data.
Hang on, you're not a machine learning engineer.
I'm sorry you're learning this time, but
you ended up doing data wrangling.
Yes, and then luckily my former colleague referenced me to Jonatan. So because we didn't work with Jonatan directly. So, and this was a beam in the light for me, because I met people with what is most amazing, sense of humor that I like, which is quite strange.
What is your humor? That's a good one.
But it's
it's super dark.
Dark and dry. And then actually people who I share values with, and who are willing to do something what I consider to be interesting and still consider interesting. So, and it was no-brainer for me that I want. So actually, I think after interview, I was this kind of person who was sending Jonatan, or like it wasn't interview per se, but it was like meeting, and I was sending him messages on WhatsApp. Yeah, are you hiring me? Are you hiring me? Like when do I start?
It's funny because I remember it the opposite.
Yeah.
I was like, he's not going to join us.
Oh, this is so funny. Like one guy is the recruiter, one guy is the. Okay, let's talk 1 minute as a rabbit hole. We do rabbit holes in this podcast, by the way. On the recruitment process going on here, because this is super interesting when you have like the recruiter and the who got recruited on the same pod. That's fun. So let's start with you, Jonatan. What is your tips and tricks, or how were you thinking about, what was the background when you recruited? You were a consultant. You were recruiting as a consultant then?
Yeah? I was a consultant, but like I said, okay, this is so...
Oh, you want to join?
Yeah, I want to be part of this journey.
So Kiryl never joined as a consultant. He was actually our first full-time employee.
Okay, so what were you recruiting for?
So we didn't know what we were recruiting for.
No, what was the problem you were solving then?
We didn't know.
Oof, now I'm intrigued.
So
tell me.
We are four founders, but we were sitting in an office and.
Sorry, I misunderstood. You are calling from Fever.
Yes.
Ah.
Exactly.
Good. All right. So now, sorry, I was back in my head that this was still when you were.
Oh, at Spotify.
Spotify.
Oh, no.
Okay, so let's back up the tape. Good segue. Good fucking segue. Because the bottom line is that you guys met at. How did you guys meet in you have touch base in Spotify?
I think we met actually at the coffee machine. Ish.
I honestly don't think that we talked that much. I think Jonatan, he's very nice and likable person, so he kind of picks up people saying, okay, how are you doing? What's your day looks like, or something like this, and.
No, I remember what we spoke about.
Really?
Oh,
yeah.
Come on, go for it.
I was helping this other company called Lexplore, so a Swedish company, using machine learning to help assess reading comprehension and dyslexia among kids. And I knew Kiryl was an ML engineer, so I think that's what we started talking about. And you were super interested to understand more.
This is at the coffee machine at Spotify.
Yeah,
right.
Exactly.
Cool, super cool. When you get the bug, you want to solve problems, and this is a good problem.
Yeah, and so that's what struck me. I really sensed that. Okay, I got Kiryl was so interested in the problem and wanted to learn more, and
So he made a good impression.
Yes, and so I think that's actually one of the strongest impressions I had from him.
Yeah.
And then we had a common friend. So when we started Fever later on.
All right. So now, okay. So that's it. Okay. So that happened now, and now you are into the game. Let's start with Fever and start there, and then we have a segue and talk about the recruitment process, because I think it's still super interesting.
Yeah.
So how did you see it? What is the lessons learned? Can we do even stronger lessons learned on recruitment by looking at both angles? That's cool.
Mm-hmm.
But okay. So tell us now the segue into Fever. And we start with that first, and then we do the recruitment story.
So the segue into Fever. Well, I'm not going to bullshit you. So we were four friends.
Yeah.
I came from Spotify. I had left, and kind of with the feeling of I loved it when it was smaller, faster moving, more innovative, and it kind of turned into a very big machine.
Yeah.
And the three others I was sitting at the same table with came from iSettle or PayPal.
Yeah.
Same feeling.
They've been on a hyperscaler journey as well, of course.
Exactly.
iSettle is huge, and all of them has sort of exploded.
And so we kind of wanted to build our new home. And so we were exploring different ideas for 6 months. And one of the co-founders, he came from Volvo On Demand. So kind of a car sharing, EV sharing company.
Interesting. We had Jesper Fredriksson on the pod, who was at Demand.
Okay.
Volvo M.
Yeah.
And he's now in Volvo Cars.
Okay. Yeah. And one of the kind of problems that he was facing was how to make the business work, because he had all these cars, and all of the cars were needed at the exact same time, and the rest of the time they were just standing still. So he had a huge utilization problem. And so we were talking about this problem and how it could be solved in different creative ways. And at the same time, another friend of ours came to us and asked, I bought a huge battery. I know you guys know tech. Can you build software to kind of run it and optimize it?
To optimize for my home grid.
This was an industry, so a huge battery. And so we really dove down into the rabbit hole of flexibility of the grid, and spent 2 months there.
Tell me the problem. So this is an industrial grade battery for what? Without maybe going into detail, or
So kind of the friend didn't really know. So he had heard about the flexibility markets and how much money you can
so
make there.
he was in the startup headspace.
Yes,
as well.
basically. And
Gotcha.
so he was asking us, like, how do I optimize revenue on this asset? I know like, supposedly I can earn a lot of money, but I need you to optimize it, and I need you to control it and understand
And what was that business model all about? Was it putting a large industrial scale battery somewhere in the grid, or
Yes.
close to in the grid?
Yes.
And selling that back to like Vattenfall or
Svenska kraftnät, mostly.
TSO? Yeah.
Yes.
Svenska Kraftnät.
But what that opened up for us was kind of understanding that the huge challenges that the grid is facing, and how much money there is in actually providing flexibility to the grid, and why that's like valuable to Svenska kraftnät. And so we spent 2 months there, and when we came up the rabbit hole, we realized that the first problem we were looking at with utilization of cars could actually be solved in the same way as a battery.
Because
is a
it
battery.
is an optimization problem, and now you're flipping it from one car sharing
Yes,
to electron sharing.
exactly. But it even goes one step beyond that.
Cool.
Because if you think about an electrical vehicle,
Yeah.
And a company only making money when it's moving.
Yeah.
If you think about an electrical vehicle as a part of the power grid, you can make money as soon as it's connected to the grid.
Yeah, because you have a demand response type opportunity.
Exactly.
And maybe explain demand response.
So demand response is you basically respond to the demands of the grid.
Yeah.
So if there is a need for more power
Yeah.
or less consumption, you can control your assets, your energy
Yeah.
assets, in this case a car, by throttling down, by turning down the charging speed.
Yeah. And what happens here is like we're getting nerd into grids, but I guess we need to do it. I mean, like sometimes in grids, my background is in Vattenfall, by the way, so that's why this is interesting. I mean, like a lot of times in the when you get further down in the low voltage, there is more of a voltage or balancing problem or consistency of service problem. So you have the challenge that you can't have too much. Then if the wind farm is blowing, you get too fucking much for the local grid. Then you have one type of problem, and if you have nothing, you have another type of problem. And if I take an example like heavy industry, like steel industry and stuff like that, high quality steel is all about very consistent voltage and current. You know, so whatever we do in order to make I'm testing if I know what I'm talking about. You want grids that basically, the more consistent grids you have the higher quality of service you have. It has very many benefits on the longevity of your gear, of the infrastructure of the transmission, as well as, you know, the quality that means the steel industry loves you and the chemistry industry loves you and stuff like that.
Yeah.
Is that a fair summary?
Yeah, I think so. I think I think, first of all, you probably know a lot more about the actual power grid than I do.
It's old knowledge, but
but
I'm leaning on it.
I think there were two things that struck me as very counterintuitive when learning about the grid. And I think the stability aspect that I take for granted was one of them. So I never really understood how volatile a power grid can be.
No one knows this shit. No one knows about, you know, we have a reserve power, we have a balancing power, we have all these different mechanisms, big business or big, you know, for Svenska Kraftnät, that actually makes this work.
Yes.
But this is basically the sign that you're living in a country when things work. I believe the country with blackouts, you kind of know all the names, like how things work. So, but yeah.
That's a good point, actually.
But there was one other thing that like struck me as like it blew my mind. So the fact that having little power in a grid is as bad as having too much power.
Isn't that interesting? This is the main thing that people don't understand. The voltage problem is a problem in both ends.
Yeah.
That I don't think people understand that as much.
So when you're driving along a highway and it's super windy and you see all these wind farms, and the wind farms, like the turbines are standing still.
And you get annoyed.
Like, what? That's windy. Just like turn.
And then we can explain it by, well, it's already full in the grid. The grid is already full.
And that you can actually get paid for consuming energy.
Yeah, because now, ultimately now, I think it's even you guys, like someone is wanting to sell solar to me, or what? I don't know. Someone is trying to sell solar to me at home. And a lot of the guys who are selling solar panel, they don't tell you this, but then there's a couple of guys who can offer you a battery in order to sell back this. But it's interesting because then you need to be an authorized dealer who has an authorized setup with Svenska Kraftnät, and I guess Fever is maybe one of them.
Yeah, we participate in different flexibility markets. So we interact with.
But this is interesting. Anyone who buys solar right now, 80% of the guys that want to sell you solar power on your roof, they are not an authorized wholesaler or dealer towards Svenska Kraftnät, so they don't have a mechanism to put a battery on your store to help balancing the grid. So that's interesting, right? I know quite a bit about this, and I had a lot of people calling me like privately, and it's like not until quite recently someone called me and wanted to sell me the battery as well.
But I guess it's more like, most things in the world, they're developing in steps.
Yeah.
I would be surprised if, like first solar panels would be selling with batteries and then offering balancing and all of it. I think we're now seeing another step in the grid balancing. So, people who have solar panels, they actually can participate in some balancing markets, or maybe they want to store battery for their houses for the future, or things like this.
But maybe this is where we do like one rabbit hole or one like couple of minutes to kind of explain what does we're going to come back to the recruitment topic, but I think as an introduction, what do you guys actually do now, and can we basically maybe zoom out just a little bit to understand some of these mechanisms, because I think it's very good, valuable information for me as a private consumer or any private consumer listening. So it's an AI topic here, but it's also a private consumer topic.
I love that. Yeah, we can go.
So please go bananas. You two take over now.
Do you want to try it? Should I try?
Yeah, go for it.
No,
Okay.
I think you should.
Well, so in one sentence, Fever, we enable a fully sustainable and resilient grid, and we do that for Europe. So that's like the scope we have.
That's your mission.
That's our mission.
Okay, and then you need to unpack this, of course.
So we have a very dirty world today with fossil fuels.
Yeah.
So we want to move into sustainable energy.
Yep.
So that's a huge shift because we're going to have a lot of wind and sun-powered energy. But that creates a big problem for the grid, because it becomes a lot more volatile, because you never know when the sun is going to shine or when the wind is going to blow. And even when it's shining or blowing, it goes up and down. And so the grid was built for a very stable and predictable environment where you knew exactly how much that was going to be produced and consumed. And we're moving into a future where none of that is true anymore. And the places that energy needs to go is not the same as before. So Fever's product is flexibility. So we offer as much flexibility to the grid as possible. So that's what we bring to the transmission owners or the distribution owners, like the grid owners. And we try to maximize the amount of revenue and value that you can get from your flexibility.
Yes.
So,
and I have some numbers here that I remember from Vattenfall, and I want to test if they're still true. So someone explained to me sometime okay, there's some unpacking. We have a TSO,
yes,
transmission service operator. They own the big national grid and the regulation of the grid. And in Swedish, this is called Svenska Kraftnät. And then connected to the TSO, you have the network operators like Vattenfall. And this part of the Vattenfall business is called the DSO, so distribution service operator.
Yeah.
So, and this is where, you know, whoever has the grid where you live, they have a monopoly on you know, connecting you to the grid on that level. So it's the difference between retail, you know, having your energy bill and your network bill, so to speak.
Yes.
And so DSO, TSO, and now comes the topic of flexibility. And I heard, you know, like the normal DSO, the view of the grid, maybe it's both DSO and TSO. Someone said an astonishing number that we have an overcapacity in terms of how much energy we have. Flipping it, we have an underutilization due to the flexibility problem. That basically we are running on, you know, based on the, you know, potentially we'd run on like 50% capacity. Help me here now. I'm trying to explain what we mean with flexibility in terms of big numbers. So in order to work on a daily basis and have our grid stable, we have like a 50 to 100% overcapacity in order to work on this. I can
give a good analogy, maybe.
Yeah,
so we need, actually, we probably should take a step back.
Yes.
I love saying that, and Kiryl laughs every time I do it. So what is the grid?
Yeah.
So the grid is the actual physical wires that connect power production to power consumption.
Mm-hmm.
So it's you can think of it as the highways and the roads that you drive on.
Mm-hmm.
Exactly the same thing. And each highway and each road has a capacity. You can drive X number of cars down this road at any given moment.
This is the good analogy. I love it.
And so if you were the owner of the road and you got paid for how many lanes you actually built in this road, you would just keep on adding lanes until you can serve the peak hour of traffic without any congestion. And that's kind of the world we've been living in before.
Yeah.
And so the road owners, the transmission owners, or the DSOs, that's been their philosophy. We're just going to keep on building out the grid until we have zero congestion, which means that 98% of the hours, you have 8 lanes, but
one car.
One car. And that's not, you know, efficient, and that's not going to work in the future. So if you draw that analogy back to what Fever does, so we take the existing roads and we just try to make the traffic a lot more fluid.
Yeah.
And flexible. So maybe you're okay with staying at home for 1 more minute.
Yeah.
Because that's going to make traffic smoother. Or you leave 1 minute earlier.
Yeah. So the flexibility problem, I think this analogy explains it well, why we have such overcapacity. But it's because of these few cold days or peak demand it is, then we need 8 lanes if there's no intelligence. So the whole topic then, as I understand it, when we now need to modernize the grids, because the grids has been sort of, as you said, very much one way, from big power plants and going sort of into smaller, high voltage, medium voltage, low voltage. I usually like the big blood vessels going all the way out in your capillaries or whatever you call it.
I was going to do that analogy as well.
That's totally, sorry, man. But that's the problem, right? That now we have the capillaries at the end, and this is where we push energy back now when we're talking about solar panel. So all of a sudden, our grids are also really much built for one-way street, one way. And now we have prosumers. I have wind, I have my car at home that we could now use the battery, or we have our solar panels, or we have all these ideas on, even companies building grids. And our grids are literally not built to go 2 ways.
No.
And by the way, that's just the electrons flowing. What about the data flowing in order to get paid and all that, right?
Yes.
So it's like it's such a shift. That means, okay, we need to change all the grids. So if we had a grid that can only go in one way, and now I need a grid to go in 2 ways. Now the core question comes for the Swedish state. I need to rip out the 8-lane highway and build a new 8-lane highway. Or maybe I should have some intelligence in there, so I only need to build 3 lanes. Is that a summary?
Yes.
That's
That's it.
hardcore. So to solve this problem with infrastructure or bare metal, so to speak, or copper, fucking impossible for the Swedish state.
Well, it is possible, but it's going to take
Yeah,
15 years.
15 years and a lot of wasted money.
Yes.
So we are coming to the topic, maybe we should have some data and AI in order to build 3-lane highways for the whole Sweden that we need to now fix everything. Or we're going to do it the old way and do 8 lanes.
Exactly.
That's the core question.
Yes.
I love this data and AI question, by the way, and I saw it early in Vattenfall, and I'm like, why the fuck are you not investing more in AI?
Yeah. I mean, it's, I think, and Kiryl, you can speak more about this, but the problem today is actually more about the infrastructure and getting access to the grid and how to navigate all these different monopolies and players.
Yeah.
That's like the big question.
Yeah, because, okay, so there's a fundamental technology problem, but there's a market problem here.
Yes, there's a big market incentive problem and a big just infrastructure problem. But what we know, like from a macro perspective, is that the way the grid operates today requires actually very low degrees of predictability or low degrees of intelligence.
Oh, really?
Because most of it is quite predictable.
Yeah.
But the world we're going into is very volatile, very unpredictable, and that's where I think AI can really play a role to kind of create a stable environment, even when you have all that unpredictability.
Yeah, and maybe another way of looking at this. Maybe because we have optimization problem at TSO, as long as you had the grid. You guys know Pontus Wallin. You're working with Pontus. Have you met him?
He's at Ingrid, right?
Yeah, with the TSO. He's
no.
one of the data and analytics guys.
I don't know. No.
Okay, but I met him. I saw a podcast with him where he explained this quite well. Where he basically said, is analytics new to Svenska Kraftnät? Of course not. They have had these balancing and optimization problems since the first day, and they've done it in different ways. But I think the big shift now is you need to be able to do this at real time, at speed. You cannot, you go from balancing on the hour to going to balancing on the 15 minutes to going to real time balancing. And why do we do that? It's because everything becomes much more, like when you have so many different types of energy sources, it's a living organism. So how would you summarize it?
I actually now want to take a step back,
Yeah.
and maybe not to talk much about AI, but it's like things are coming in steps.
Yeah.
So I think let's say we have now a lot of electrical vehicle cars in Sweden specifically because there were like easy way for buying cars, like Swedish government was sponsoring it, and then how electrical vehicle car is used. Someone goes to work, comes back maybe around 5-6 in the evening, the most expensive hour. As the user of electrical vehicle car, I don't want to pay a lot of money, and maybe I probably will not use my car until 7 in the morning. So, and maybe I need to charge it for 2 or 3 hours. Do I need to charge it right now at the most expensive hours? Probably not. So this thing is called smart charging. So this happens at night. It's no AI is needed. It's more or less you need to divide one number by another to understand how many minutes you need and what are the cheapest hours during the night. And
Not
already,
rocket science.
and already we're doing some peak shaving.
We can do peak shaving in a very pragmatic way, but we need data, by the way. We need to manage data at least.
Yeah. But I think, this is like market or electricity prices in Sweden help us to do this.
Yes.
So like if you're charging your electrical car during the winter, you don't ever want to do it at 6 in the evening. No
and
way.
everybody can, you can follow the spot market like this. Everybody can do it.
Yes, and then, like even these electrical vehicle chargers, which are not maybe the best piece of software, but they also can fetch these prices and charge your car.
I have a Tesla, I put a scheduling on, very simple.
Yes, so
no
I think
AI needed for this. By the way.
So in a way, we can talk a lot about AI and everything, but there are like some simple things that
everybody can help.
Yeah, exactly. So like, okay, we have a load with a new thing, electrical vehicle cars. We can do this. Sometimes, I'm not sure. I think iPhone in US does the same.
Yeah.
They say, okay, we will charge your phone during the night because this will help everyone in a sense. So for sure, future is AI driven, and we will absolutely need it. For now, maybe we can just charge our electrical vehicle cars during the night.
So behavioral change takes us a long way. If we can, because this is ultimately about people changing their basic behaviors to help out and be smart about their wallet and be smart about helping the grid.
Absolutely, and then the same thing maybe will help us with solar panels and the battery at home. Maybe you charge your battery during the day with the solar panels, and maybe at hour 6 or 7, when the consumption is the highest and the price is the highest, maybe you can use your battery to power stove, or I don't know, like things like this. So always, when people talk about AI, I think, yeah, sure, on the way there, we will have some heuristics that will absolutely help us.
Yeah, but okay, so maybe that's the connection then. So where is the AI in what Fever is doing, and where does AI come into, when does it become a real play, or how do you see this? If you sort of start, if you continue the journey that we can do a lot without AI, but what is Fever doing, and where do we really, really need AI? I think you can start.
Yeah.
Yes, I actually had an interesting conversation with our CEO recently. So we are now maybe in the state when we are kind of selling, balancing to people, where we say, okay, there is this market where you can earn money. So, and in this way, we're helping Swedish grid to have more assets, and then like to have flexibility, and then, to help future. So basically now we're saying, okay, please buy the battery, come to us, you will get money, and then we will help Swedish grid. So for now...
Is that the core business right now, Fever? Like, can you explain the core business like this? Because I think I know it, but please, I don't think everybody knows.
Yeah, the core business is basically to offer up the technology of being able to do balancing or flexibility trading and control for companies that can't. So utility companies like elbolag, or infrastructure owners that own a lot of different batteries or EV charging spots, they don't have the tech team in place in order to build the infrastructure to aggregate all these assets and trade towards Svenska Kraftnät and the TSO. They don't have the ability to predict prices and orchestrate all these assets. So they buy that service from us. So we call ourselves a VPP as a platform.
Virtual power plant?
Yes, exactly. So as a service.
So the core topic is that Svenska Kraftnät has a strong need and a strong monetary incentive to balance the grids. And basically they can come to a point that, we need to do a major investment to fix this grid. Or if we can find something that helps us balance this, is the VPP service.
Yes.
We can live in these grids longer. And on the other side, you can then sell a service to different companies where basically say, hey, you can make if you have extra spare power, or if you decide not to use your, if we can sort of help you how you use your power, and you in this way help Svenska Kraftnät, you can make some bucks on that.
Yeah.
Is that that's the core thing here? Yeah.
Yes, and then where kind of AI or machine learning helps us here. So we are like saying, okay, this is the amount of money that you will get from us. So in this market, so we want to our customers have like the best possible experience, and we want to have as many assets possible in European market, so that the future of electrical grid is bright. So, and then our goal now to attract customers is actually to place assets right in the market, meaning like, okay, what are the best prices, what are the best products, how do we predict it, and things like this. So this is when it comes to money, but also like there are different types of flexibility assets, electrical vehicle cars or chargers. In this case, it's very interesting machine learning topic. In a simple case, you can explain it. I need to predict how much load chargers will create to the grid. And when the grid doesn't feel well, we will stall some chargers and grid will feel well again. And then since we're dealing with the question of national security in this case, because electricity is national security, we don't know to overestimate our abilities. This is no for us. But also we want
Optimize.
we want to like earn some money for our customers. So this becomes like a problem, of forecasting, and then it's like,
and it needs to be a robust forecasting here.
Absolutely, and then we're getting PhD in electrical vehicle users' behavior now at Fever. So just to make it better. So right now we have like some prediction problems, we have some optimization problems. Also on top of it, since I mentioned it, it's like national security question. So it's not like we like over predicted something and then we can feel well about it. We cannot.
But okay, so and Fever is operating in which markets? Is it a European footprint or is it a Swedish footprint? I don't know.
So currently only in Sweden.
Only in Sweden?
But the clear goal is to go across Europe.
Yeah.
So the good and bad part of the European grid is that it's all built kind of the same time, so it all has the same problems.
Kind of the same functions, yeah.
Yes.
And could you argue that whatever market you are going into, one of the key actors that you're working with, or customers, if you like, it will be the transmission operator on the one hand side, or is it other models you could work with?
Yeah, so I think right now in Sweden it's, like Klondike. Everybody's going to buy a battery and everybody wants to dig gold.
Yeah.
And that's specifically for a market called FCRD. So it's frequency containment reserve. So FCR is a market for managing the frequency of the grid very quickly. And this is just a gap in the market, and so there's a lot of value in that market, meaning that the TSO pays a lot to participate.
But that particular market, is that then connected to our physical commodity market like Nord Pool, or how
Not directly.
Or is it more connected to the TSO?
Yes. So this is
so this is actually from a market perspective with the transmission service operator, because they need to balance stuff.
exactly.
Yeah.
So the way the market works is that the TSO each hour of the day, every day of the year, buys in a certain amount of capacity. So they want to know that they have X hundred megawatts of capacity in case something goes wrong in the grid. And that wrong is currently, I think, is if Oskarshamn 2 goes down.
That's one of the power plants.
In Sweden. So the entire Nordics, so all countries in the Nordics, share this responsibility. And in Sweden, the market is extra lucrative for various reasons.
Okay.
But when we think about flexibility, this is one market. Flexibility could also be traded at Nord Pool, like in the intraday market, where energy companies try to keep their books in balance. That's exactly the same problem we're trying to solve, just on a different time scale.
Could you work on that? Could that be an opportunity for Fever, or are you guys working?
Absolutely.
Is that a part of your portfolio, working at Nord Pool with this type intraday stuff?
Not right now.
Not right now.
No. And the reason is basically that if you look at each hour of the day, the answer to where to place your flexibility is always going to be FCRD. But that will change over time.
But so do you guys now, so TSO is a very important, the transmission is a very important relationship for Fever right now.
Yeah.
Are you engaging, or do you need relationships with the spot operators like Nord Pool, Epic Spot, and the other, the European players? Is that going to be part of the big play, long-term play with Fever?
It could be. I think the way we think about it is our customers could be the balanced, responsible parties. So the parties in this market are responsible for making sure that there's as much consumption and production in the system. And they usually trade on these markets in order to keep themselves in balance, but also to get as much value from the energy that they produce. And so that's our customer, and I think we'll go to market either through them or on behalf of them.
But I think you answered it. Let's see if I get it right. I mean, like, ultimately, we have a balancing and flexibility problem, and it's in the best interest of all the actors to figure out the market mechanisms that lets us use all the different levers. So if you stare yourself blind on one particular lever, at some point that gets overheated part of the market.
Yeah.
And then maybe Klondike here, but maybe if we do it, if we take a step back, we can do this part of the problem at Nord Pool or Epic's, in this way, and then we have this way, so it's an ecosystem optimization problem also. So it's also an ecosystem of markets. That's what I'm trying to get to, I guess.
No, you're completely right.
Yes. So, for example, as of today, we're kind of like thinking how we best participate in balancing market.
Yeah.
I guess maybe in 2 years we will say something like this. We will have 1 megawatt of flexibility. Which market at which hour we will bring this megawatt of flexibility? What state we will be, like where it will be the best for us, and also like it's not only about money, but it's actually when we get the most money in the hour. That means this is the place where the flexibility needs the most.
Because this to me is super interesting, because if you now has one of your more core competitive advantages to really understand the optimization problem and have the right algorithms, how to use that and how to create a user experience or a product out of that, it's potentially, it's a little bit like you said, you could take a transport problem of M and you could transport it here. Now, here you have the fundamental understanding what you need to do. So here probably, am I on the right track here, how you're thinking?
I think so, yeah. To us, the choice of where to place our flexibility comes kind of last.
Yeah.
Before that, we need to understand how much flexibility actually exists.
Exactly.
So there's a lot of prediction that goes into what Kiryl just spoke about, understanding the EV fleet, for example, understanding how the weather will impact the grid, understanding constraints in the grid.
No, but could you then summarize to some degree the companies with the most robust predictive power in terms of being efficient and sort of optimizing the money but being safe? That becomes a very, very strong competitive advantage that you then can think about how to use.
Absolutely. And so like if we talk about future, when there is like we tried heuristics. Worked well, not good enough. So the future will be for us to understand, okay, how this market is influenced by weather, by people, by industries, and how we can utilize our assets there. So this will be kind of like the future optimization there. And then, as you said, the one who will understand it best, who has like best prediction, best understanding of the market. And I'm not sure like predictions will be enough because it's, as you also described it's kind of like living mechanism.
It's real time, so you need to have prescription. You need to get to an automated optimization algorithm.
Yes.
So what we are saying is, it's not enough to predict; it needs to execute.
Yes, absolutely. And then, like when we're talking about like AI in electricity, I am always thinking about my backend colleagues who are doing amazing job of making our backend available, like 99.99999. And then actually how they're like treating batteries, EV fleets, and all of this. This will be absolutely on par, important with all the predictions.
Yeah. So if we move into that and maybe do it as one rabbit hole more, because we are on the flow now. We take recruitment soon.
You're just dangling that as a
I love it. What is the future? Can we sort of summarize a little bit about the future grid? Because you're already moving into that now. So the predictive power becomes super important. But you said it's more than that, because it's the whole availability of the whole infrastructure and the software and everything that goes around this. Because it's not only now hardware, bare metal infrastructure. It's the hardcore data pipe, everything, right? So could we elaborate a little bit about the future grid here? Where this, what have we said now is sort of almost hinting at something.
Yeah.
Could you try to nail it down for me?
Should I start with the macro pieces and you can talk?
Absolutely.
Macro. I like that.
So the big things that will change is we're going from stability and predictability into something that's unstable and unpredictable. And that's mainly driven by the sources of power.
Yeah.
So you have coal and gas today and nuclear, and that's all going away. And instead, you're going to have much more wind and sun powered. So that creates a lot of volatility in terms of when power is produced. So that's kind of the biggest changes.
Drivers that you can clearly see already.
Exactly. And then change number 2 is what we've been talking about, the places that energy will be produced and consumed. So EVs, for example, are going to have a huge impact on where energy is needed and how quickly. All houses with sun, like PV on the roof, will also change where energy is produced. So production is going to become decentralized. And intelligence is going to become decentralized instead of being concentrated in certain power plants and in certain control rooms. So I would say that that's kind of the big changes that are happening.
And where does this leave us on more technology, infrastructure, and even down to data and AI?
Yeah, absolutely. So, like, I like to explain this with the following example. Future house will absolutely, for sure, have solar panels, home battery, and electrical vehicle. So, electrical vehicle will have also batteries that would be able to power homes. So, actually, maybe at certain hours, people will power their homes with electrical vehicles, the batteries that they saved power during the day. So, and this will be optimized. Our goal will be at this point of time saying, okay, what should we do now? Should we sell the energy from the battery of a vehicle, electrical vehicle? Should we charge it? What happens with the battery? Solar panels altogether, and then how it will work altogether? Or maybe, if you have some energy, would you like to sell it to your neighbor? Or like simple things, I believe, like future of Swedish BRFs, they probably all will have batteries. They will charge it, and maybe they will use it or sell it to neighbor batteries. So the same situation that we see now in Ukraine, for example, when it's like all centralized, and then there are like power plants are bombed, and there is no electricity. Probably this will not be a case in the future. So probably we will buy energy and sell energy to our neighbors in the same neighborhoods. So it will be kind of like the same as Swedish neighborhoods looks like now. You don't need to go to city center to buy, I don't know, clothes. You will have everything near your house.
But can we unpack this optimization problem a little bit? Because I sense that there is an optimization problem simultaneously on different abstraction levels. So very locally, how you do it here, but then you can take the market perspective, and then you can take 3 market perspectives, and then you can take high voltage, medium voltage, low voltage perspective. So you need to have an optimization of the whole ecosystem versus the capillary at home. So that seems crazy. I mean, like, it's such a complex problem. Maybe it's many problems. Is this one big model, or is it many small models orchestrated, or
I'm quite looking to solve this, or like to at least participate and try to do this.
This problem
exactly.
is your favorite problem. Maybe.
Exactly. So, but I think it's also like, as like, I hope as much as I imagine it will be decentralized. Yeah. I think we still like it's the same with the huge computational systems. You are solving like one problem in one area at a time. So, and this will hopefully help the whole grid stable enough to like small area working, a lot of small area workings. The whole grid is actually working.
Yeah, because very early on in Vattenfall, I'm working now with Scania a bit, with Boliden, and there's been a trend that is getting more and more obvious. For me in Vattenfall, this was obvious in 1819, that monolithic approaches will not really cut it, because you could see like we will have at least intelligence on the edge in some ways, and then we'll have central intelligence. If you look at the cars, okay, you need to get a compute in and maybe build a model, and then you need to push it out in the car. So this is just one angle. And then I mean, participating is on the advisory board for ENLIT, European Utility Week, and I hear them sort of talking old school data warehousing on old school monolithic views of how to optimize this. And I say, like, this is clearly many, many hardcore problems on its own. So it's going to be about optimizing, I saw this as a very decentralized problem. And where you then maybe have an orchestration problem. And so I started to dig myself into federated machine learning, all these different things that was sort of going in this direction. And for me, this is super obvious. And I don't, do you see it different, or I cannot see it other way in any other way than distributed?
I have a I think we as a Fever we have very interesting experience that we discussed because we've met a lot of people who are very knowledgeable in energy grids, etc. And they're basically, you can quite easily separate them into groups. One group is people who are like 60 plus years old, because grid was kind of like solved for a lot of years.
Yeah.
So these people were like young, ambitious, they solved the grid, and we actually didn't know how it works because it worked perfectly. And the second group is actually like graduated PhD students who just graduated, and they have completely different views on the future of the grid, where, you know, like people who are like work a long time, they're like, no, we should keep it as it is. So it should be how it is, centralize everything. And the new generation, they're like more cowboys, decentralization, more like flexibility, more green energy. And
what do you think? You know, what is the sort of, what is Fever's bet on this? More distributed, or because I find it, just looking at what you, if the drivers you explained are true, it's distributed. It's an edge here. It's a prosumer dimension in this, whether you like it or not. And you can't put the genie back in the bag.
I think you're absolutely right. I think that's what I mean with decentralization. I think a lot of the decision making and logic will move to the edges of the grid, or the capillaries, as you say. I think that's going to have a very, very big impact on how we operate the grid. But I want to hit on your kind of point on there are many different levels.
Yes.
And even, you know, the Nordics is one synchronous area, and it's going to be connected to Europe. And then Europe is going to be one big area. So whatever they do down in Italy is going to affect us up here in
this
Sweden.
is, we're talking about our price zones.
Yes.
Price regions in Sweden. And why is the price region in southern Sweden always more expensive? Well, it's connected to Europe.
Exactly.
Don't forget that.
So I think for Fever right now, we need to focus, because even though there is, you know, the theoretical one mastermind that can understand what goes on from the highest level down to the single household, I mean, we're not there yet. So what we're doing is we're saying whatever happens behind the meter, meaning within a home or within an industry, that's for somebody else to optimize and solve. So
you are basically betting on carving out pieces of this algorithm problem of the whole ecosystem.
Yes.
No one can solve it all.
So the algorithm and the problem we're solving is what happens between the energy meter and the grid, not between the energy meter and the appliances that kind of
at home
or the industry. So you'll see over time user behavior changing, and we go back to kind of the counterintuitive notions of I have, you know, a PV on my roof, and I see it producing power and feeding the grid. Why would it be more beneficial for me to turn this off? How can I get more money by turning off energy production? If a user doesn't understand this, they'll keep on producing energy even when it's not needed. So as soon as users understand, okay, this is, you know, an orchestra of participants. Okay, I'll turn off my sun production when it's needed.
Knock-on effects.
Yeah, then that will have huge knock-on effects. Back to Kiryl's point about smart charging. That's great, but if everybody smart charges at the exact same moment, the grid blows up. So I think you'll have extreme waves of kind of user behavior changing kind of the downstream impacts, which is like our world in part.
All right. But, you know, let's see if Anders joins us, but he would be very mad at me with having people who knows Oh, you want to do... No, he's not coming. Okay. Should we do news section or not? Let's do it now.
It's time for AI News. Brought to you by AIAW Podcast.
Just in the middle of the conversation break, and then we'll continue. So we try to... it started with literally last season when with ChatGPT and everything going bananas in terms of new LLMs or anything. The AI world is spinning by the week and has been for a while. So we made a point to basically see if we could pick up on, was there any news, things flashing by on the news? And it can be sort of gossip news, or it can be real news. Anything from investments to tech to a new LLM or whatever. And we spend a couple of minutes and reflect on it. So we haven't prepared this at all. So I'm gonna shoot to you. Do you have any things that caught your eye in the news? I have a couple of topics, or one topic at least. But I'll ask the guest first, and you can, if you don't have it now, you can think about it, and you can go after me. But I just want to be polite to ask the guest first.
I read actually an interesting paper, but I'm not sure if it's news. So the paper that.
Okay, but I humor you. So what's news to you this week? Which one was it?
News this week. Actually, yeah, I'm not sure.
No, but I think he's saying, what's news to you? So
if you read the paper, let's go with that.
Right, with paper. Yes, okay, with about paper. Yeah. So the paper was that I'm not sure how you spend your teenage years.
Yeah.
I was debating people on the internet. So this was a very important part of my life. And then I guess it's very important that this debates that you win the debate. Otherwise, what's the point? And then, there are like famous US election where people claiming that, okay, there probably were some bots on the internet actually converting people's opinion. So the paper is coming, I think, from Swiss, Italy researchers. So they wanted to build a platform and actually to check if ChatGPT specifically can convince people more than actual people. Setup of this experiment was following. They had like 820 people, I believe, and there were like 4 groups. So there was like human versus human versus ChatGPT, human versus human who know personal information about other human, and human versus ChatGPT with also personal information about human. And personal information was something very simple that we can get on the internet. Age, ethnicity, work, education, things like this, like Facebook profile, basically. And they picked around 10 questions, which, you don't need any prior knowledge to. So the questions were like, should rich people pay higher taxes? Is using social media making people stupid? Like easy questions, I guess most of the people have opinion about it. So, and the debate was like this person was giving a random opinion, maybe even the one that they didn't support, and then they were debating it for 10 minutes. And then at the end they were checking, okay, what's the result? Have you changed your opinion? So the result without personalization there, not very interesting. Interesting part was that ChatGPT was convincing people much better compared to human with some personal information. In this paper, they provide some prompts, which were quite simple in this case, and I was surprised how simple they were. And that means that probably someone with access with ChatGPT similar model can convince people on the internet to like things that it wants to convince to.
So, which is pretty scary, because now it means that you can now do things at scale.
Absolutely.
So what's the point with this? Like you can use ChatGPT. It actually means that you can start robotizing or automating setups in order to convince at massive scale.
Absolutely.
Because people couldn't do all this convincing, but if I now can program it and it does like 1,000 at a time, and then 1,000 ChatGPT's conversations going on.
Yes, and then I said like prompts were quite simple.
Yeah.
So if there is like some mastermind who has like knowledge about convincing people and like techniques and things like this, I think it's like it's a weapon.
Yeah. So with the right prompt engineering techniques in order to set up the structure to get the LLM tuned on the right way of thinking and arguing, interesting, yeah. Quite scary. I think I saw that blink through. Maybe I think it was a couple of weeks back that this came out.
Yes.
But it's quite interesting in terms of election times this year, of course.
Yes, I'm specifically interested about it because there are different products that are based on large language models that are developed currently, and not many of them catch my eye, I would say. But these things, which these are super interesting to me. Like basically how anyone can use this to do like something that we couldn't do before.
Yeah. Cool. Any news that caught your eye this week, Jonatan?
I have a 1.5 at home, and
Yeah.
I'm like addicted to chess. So I haven't read anything this week.
That's cool.
Unfortunately.
That's cool. I can take one, and then you can. Do you have a couple today, Goran?
I see that you're calling on, you're checking on the one that I had, like, so you continue with that one.
No, but I think the big one. I mean, like working in the data and AI space, and of course, working more with the sort of normal enterprises. You know, you get all these normal players that we always hear about, the Snowflakes and the Databricks, the Azures and the Microsoft. And it's been a game now going on where sort of it's been the Microsoft or the Google camps a little bit. Okay, we have the Meta. And I think what happened this week is that Databricks really got into the game. Have you heard about them releasing their first open source LLM model? You can bring it up there, Goran.
Yes, it's there.
Yeah, so it's the DBRX. That's what they call it. And I find this whole play very, very interesting. There are many things that makes this play super interesting. So first of all, they go all in on the whole open source angle, right? They are open source now, and they are then, you know, really benchmarking themselves against the other open source models, and they can clearly beat Llama 2, Mistral. They're doing better than Mistral on some key benchmarks, and they're also doing better in Grok. And of course, then the DBRX model, I think in size is is slightly bigger, right? So I think, what was the size? I forget. Llama is 70 billion, whilst DBRX I think was over 100. Do you have the number, Goran? Help me out. So it's a fairly large model they have put in place. And I read an article a little bit. It was an article in Wired where there was a little bit behind the scenes. So they invited Wired, like the magazine, in order to sort of follow them the last 20 days before launch. And it was one of the cool things was that they had like 10 days left of compute or 20 days left of compute, and they was like, okay, we've done it more. Should we just go hard, or should we change strategy for the last hours of compute? And they went a little bit different. I don't know if you heard about all this.
No.
It's very, very interesting, right? Because you get a little bit behind the scenes on the training strategy. And then ultimately you end up in the big debate, you know, or big discussion, and their marketing spiel, of course, why it should be open sourced and why we need to get a more transparency and with less secrecy around how do you tune and work models? What do you actually do? So there are many angles on this. The last angle I want to point out is that it totally makes sense to me that Databricks, who sort of, they're open sourcing the model because they want to make money on the compute, and they want to make money on the lock-in effects to Databricks. So they can actually find a killer app to drive the revenue model in another way. So of course they can open source it because they, you know, what they lose on the carousels, they can take back on the swings. So it's interesting, right? So how depending on which player goes into the market, it opens up different business models.
What was their strategy with the last 10 days of compute?
It's called, this is where Anders should have been in. It's called curriculum training. So basically what they did, I need to find it. I need to read the article. This is the wrong, I have it here somewhere. So it's, for everyone who's interested, there's a Wired here. So if you go into wired.com, inside the creation of the world's most powerful open source model is sort of the clickbait title. It's a cool title, by the way. So startup Databricks just released DBRX, the most powerful open source large model yet, eclipsing Llama 2. And then it goes down and sort of goes quite into detail of how they did that. They're talking with a guy. I mean, like they hired a guy that came from, I mean, like the starting point is that Databricks acquired a company. I forget what the name is. That was quite strong on this. Let's see. Inner Workings. Let's see, we get down here. Sorry, I open up. I missed it now, but I think it's called curriculum training, and you know, I'm not the kind of guy you should ask on this detail level. It's fully beyond me, but you know, not only brute force of more hours on the same setup, but actually starting to tune it or giving it different data sets. So it was this combination. Do we train it on specific data? Do we groom it on a certain problem? And I think it was called, let's see if I can find it.
I think it's always quite interesting when the companies does something and you cannot actually say they're doing this because they're nice or just because they want to earn money.
No. What is it then?
No, but it's like, because like, you know, every time someone's open source something, we're like, yay, nice, amazing, go open source. We all love open source. But on the same time, probably, as you said, they're driving, you know, attention to their their business.
It's a business strategy.
Yeah. Open source, if anyone haven't noticed that, open source is hardcore a business choice. It has always been you know, when back in the day when they released the BERT model or whatever they did, and when the TensorFlow was released and all that, it was ultimately to get massive performance improvement for free in terms of people working and fine-tuning and fixing the bugs and all that. So open source must be a business strategy. Like there is no other strategy. Then you can have what is the optimum sustainable business strategy that is also sustainable for the greater good of humanity. I think that plays on that you can have different values on this. But to naively think that open source is charity, no. Of course not.
We actually had one of these discussions today. If parts of what we're developing should be open source.
Yeah, but and that could be a very good idea, but it needs to make business sense.
No,
of course. Okay, so different team members threw out ideas in Slack for how to use the remaining week of computer power. One idea was to create a version of the model tuned to generate computer code, a much smaller version for hobbyists to play with. The team also considered stopping work on making the model any larger, instead feeding it carefully curated data that could boost its performance on a specific set of capabilities. An approach called curriculum learning. So that's, in the end, they were not, you know, the team was sort of debating, and then the head guy said, we're going to go for curriculum learning. So instead feeding it carefully curated data that could boost its performance on a specific set of capabilities. An approach called curriculum learning. So and they made that, and the core point was that they could measure a significant uptake in model behavior by basically then tweaking the training. You know, so there's so much alchemy going into this now, right? That's quite interesting. That's a cool topic. Do we have any other one? You want to add another one?
Yeah, I think what is interesting with this topic is how much money NVIDIA made on this. So the DBRX was trained on 3,072 NVIDIA H100s connected to 33.1 terabyte.
What's each one?
H100 is basically...
No, how much is it?
Approximately like $50,000, something like that, maybe a little bit more. Actually, that is a good question.
Yeah, how much?
Because he has like a new, he just announced the new one, which is H200 or 300 or something like that. So H100 NVIDIA.
I've seen today a photo of Mark Zuckerberg and NVIDIA CEO. So probably Facebook bought a lot of NVIDIA's GPUs again.
That was already done.
And NVIDIA CEO allowed Mark Zuckerberg to wear his jacket, his famous leather jacket.
Okay.
I think
so
like
if he allows him to wear the jacket, he has paid.
I think that is a news by itself.
Yes.
So Zuckerberg
Should Zuckerberg give his
Jack Ma's
sweater?
jacket, right? Jack Ma, right?
No, not Jack Ma.
No. Sorry. What's his name? Justin.
Yeah, it looks like it's $44,000.
So 44,000 times 3,000.
Yes, exactly. All right, so it's only that.
That's a lot of leather jackets.
That's a lot of leather jackets, yes, for sure. On another note, when we are talking about Zuckerberg, of course, and Meta, do you know about their glasses, right? The Meta views. So next.
I tried these actually, the Ray-Bans.
Yeah, I have them as well. I bought Australia, but they were completely
Useless
in Europe because they're connected with the app, and the app was not basically applicable due to regulations.
But now it is.
But now it is in 8 countries or 15 countries or something. So it's not in all of the countries.
It's in Sweden?
Yes, and now there is a different thing that is adding. So they are adding now multimodal AI into the glasses. So basically it can you can prompt by speaking, and then it can because it has 2 cameras on the side, it can actually see, and then it can give you information like this is a museum, you will find this, and in the future probably you will be able to buy some stuff. I think it's going near to what Apple is trying to do, but what is interesting is the where are we moving with all this technology. So if you see 3 emerging technologies are really, really starting to pop out. So it's AI, AR, and robotics. And it's all over the place. And if you looked at NVIDIA's release like 1 week ago, 2 weeks ago, it was all about that. So they were basically, they're preparing for the chips for this. They are also now making like an open source training models that you can use and deploy directly to train robots and etc. And I think eventually why Elon was super pissed at Sama. It was not because of the open AI. It was about
the robot.
The robot. Yeah. So very interesting. All right.
I actually tried these this weekend. I was really impressed.
Yeah. The sound is still a little bit shitty because when you run it's just like a little bit flat. Like he's here.
Okay. I didn't try running with it, but I do think the music part of it, like the sound, is pretty cool.
Yeah, and you can talk with them. You can take basically notes and stuff like that. I think it's great. So but it's also dangerous. You don't know where you're going to be filmed.
No.
Oh,
so
exactly.
I'm just assuming somebody's always filming.
At this point in time,
at this room,
I
it's
was
easy.
I was in a conference in Singapore. We were doing Data Innovation Summit in Singapore, and we had actually one of the speakers was coming from Meta. He comes down. He's coming downstairs, and we're having like a. I think it was the first coffee break in the morning, so we were having a breakfast or something. I'm looking at him and I'm looking at the glasses, and I can see because if you have had Meta, there is no way you will miss that somebody has those because of the 2 cameras that are on the side, right? So it's like you have Meta. So I was like, I film sometimes and I make it like this. Like it's very, very,
So he has Metas that is not Sunnies. Were they Sunnies?
Yeah, exactly. So I have the ones that are completely sunglasses, and now there are the other ones that are basically you can change it. So it's like
polar.
Polar. Yeah. Good.
All right. So let's move back into the topic. I want to change gear a little bit, and when Anders listens to this, he will be very, very mad at me if I didn't even try to have it a little bit techie conversation. So I think there are a couple of topics. First of all, a little bit like what is the data and engineering challenge that you're working on, and let's not stay on the macro discussion, but let's please. It's going to be more detailed than I understand. I don't care. There are listeners who So what is the actual engineering problem, and what is the algorithm problems concretely you're working on?
Where to start?
Yes.
So many things. I think me and my colleagues, we end up maybe 2nd or 3rd times in our engineering careers where we work with something that is not stable enough. So many of my colleagues, they're coming from iZettle. And then they're like saying, okay, when we started iZettle, or we like at the beginning of iZettle, payments were like unreliable, like not possible, like sometimes you can charge user 10 times, unfortunately, and the same thing. I was working at a startup where we're developing offline maps for like Android devices as well. When someone would report us a problem that my very bad cheap Android device cannot render your maps. So and then like okay, what can we do in this case? I think the very basic challenge is now that we're having that all of these flexibility assets that we're dealing with is quite unstable. And there's like sometimes like batteries and then electrical vehicle chargers. They're quite hard to control. But we should do this, and we should be like stable as possible because we're dealing with electricity and grid and balancing. So there is like no way we can do our work bad. So this is like very basic problem that we're having. We're writing software for unreliable devices.
What are the key topics to think about when you write software for unreliable devices? What do you do?
First thing is more like thinking, okay, what we always think about. Okay, if we ask device to do something, will it do it? We ask like do it 2 times, or like okay, we check it didn't do it. Okay, should we send a new command? Should we wait? Should we ask a new device to do something? So like key thing is more like to learn from our previous experience what should happen. Let's take example electrical vehicles. So what happens in the grid when the frequency drops until certain level, we need to stop certain amount of devices. And let's say we have 500 devices now, we need to stop 100. And then this is not only 100, we need to pick certain load of these devices. First problem that arises, okay, which chargers do we stop? Very interesting algorithmical problem called sub-sum problem. So basically, which devices you want to pick, so their sum is actually equal exactly to the number you want. You can go a little bit higher, a little bit lower, but then if you go too low, you don't do your function. If you go too high, you kind of depleting your fleet in this sense. Okay, then we're sending commands to these devices, and then some devices, they say, whatever.
Try again. I don't listen to you.
I continue doing what I'm doing. Or some devices, yeah, I'm stopped now. And then in 1 second, I'm started now again. And you're like, yeah, but we had this conversation before. Please stop. Some devices not replying at all. Some devices saying, thank you for your try. I'm actually leaving now because my user wants to drive somewhere. And so, this is very basic engineering problems.
So this is software engineering when you have a lot of different scenarios, uncertainties, and you need to think about to make it flexible, I guess.
Absolutely. And then, the thing is, okay, we can learn from data. So what is our strategy in this case? Okay, this time we tried to stop 100 chargers. Let's say X% of them stopped. What is our strategy next time? So, okay, this charger or like this home battery was misbehaving. Like we can maybe, like when it comes to home battery, we can, send message to users, say, okay, your battery is malfunctioning, maybe you should do something with it. What can we do with the electrical vehicle charger? Should we exclude it? To what should we do? What should we do with in this case? So, and it's kind of like trial and error. So we run like a lot of experiments in this case, but it's also experiments are quite costly in this case because it's like actual users. And sure, we can stop devices. What is quite important also, we shouldn't forget to start devices because some users, I guess most of them, they're known for this. They will be pissed off if their car is not charged in the morning. And then they say, yeah, amazing flexibility things, guys, but I need my car charged in the morning. This is kind of important for us. This is also a problem. Like we're dealing with, on one hand, we're dealing with TSO, that we want to fulfill our obligation. On another hand, we're dealing with customers.
Many of them.
Exactly. Yeah. And so I would completely understand if something happens with, I cannot drive my car. And then if I cannot drive my car, if emergency happens, it's, it's even more complicated. So before even we're going to some data land or something. So we're now dealing with devices which haven't got, a lot of attention during recent years. It's changing. It's absolutely changing. But it's also this industries, the energy industry, getting a lot of attention. So many companies, they're becoming much more better. They're hiring better people or more people. Everything becoming better. But it's still we're still not there yet. So we have a lot of in first place engineering challenges. How do we even if we did the best predictions in the world, how do we operate our electrical vehicle fleet? So first there is algorithmical problems. How do we don't deplete fleet? And there is software engineer problems. Okay, how do we store our state? What if our service goes down? What if data centers that we're hosting our services goes down? So this is all very complex challenges that we need to overcome. Yeah. And quite important for us that we try to pay attention to it from the day one.
But I think this is quite important, profound lessons learned here that I find when you look at more analog companies that think they're going to do analytics and AI and they don't have a real software engineering background. the naivety in relation to what is the product? Oh, it's the algorithm. Going back to Google's the technical depth of machine learning, it's so obvious that you need to, in the end, even in very basic, much simpler examples of BI or analytics, you need to think software engineering. You need to think end-to-end system, and then put your attention where it really counts. So what you are saying is that any machine learning or AI or any cool gadget that you're playing, first of all, we are building software, and then in that software, this comes fancy algorithms, if it's RAGs or generative AI or whatever. But don't forget that what you're really dealing with is software engineering. Would that be a fair summary?
Absolutely. And then, like some very basic things like on-call. So, if battery go bananas, we need to know about this. We need to be waking up. Or I sometimes feel like, sorry, not sometimes, I always feel very sorry for my colleagues when I kind of mispredict something. When I am like too positive, though we're trying to be as conservative as possible, but we're trying to predict few hours before operation if we're able to fulfill our promises to TSO. So basically, like sometime before that, we have time to call and say, "Yeah, sorry, this is emergency. We did it like this. We didn't expect it. We tried our best, but this is how it happens." It's usually never happens, but if it is, we need to do this. So, and this should be in place, no questions asked.
So step number one, when we talk about the engineering challenge, what we're doing, it's a software engineering challenge, and it's a software engineering when we still have unstable or not so mature devices to deal with. Got that. Humor me now, if I still want to talk about what is the algorithmic dimension of this, what are the types of machine learning techniques? What type of mathematical algorithmic problem is this optimization problem?
Yes. So for now, we are we're not solving that much optimization problem as like I described about like future. Mm-hmm. So like let's say I will name two main problems that we have now. Mm-hmm. First one, we need to predict how much load we will have from electrical vehicles, and then how we calculate it. So basically, you have a graph, or like you can like think about it like every day. We need to predict in the future 24 hours how the day will look like for certain customer in certain area. So this is like the load for the grid. Mm-hmm. Like saying this hour we will have 1 megawatt of EV like power during this hour. And how do we do this? How we do this like predictions?
Yeah.
So
what is the techniques that
So this is like time series forecasting. Yeah. So everything works here like in a sense. So like
you could try different machine learning techniques for time series type problems.
Yes, exactly. So there's like some very simple ones starting like that when we're starting like with ARIMA, PropHet libraries. So then we tried like a boosted trees, which are, I think, working pretty well right now. The next step is more like we try more like deep learning approaches, or like more modern approaches, I would say, in this case.
And now is the Occam's razor type topic. Use the right algorithm for the job, or the right eraser, the right. So you can go bananas on deep learning. Why would you go deep learning, or why wouldn't you?
So I would say like this: it's also like the amount of data which we're talking about, like, is not huge. We're talking about like 24 values per day, and then we have like I don't know year maybe of data, or like year and a half max of data. So can we utilize it? So how this will utilize it? I think what is interesting here, like, is more like, okay, we have few customers with the similar fleets. How can we train maybe the one model using all of their data, if they're fine with this, like, because it's anonymized and it's like
federated machine learning style,
like something like this, and then like, okay, can we? Because we always have, like, when we have a new customer, we have a cold start problem. Yeah. So when someone comes to us and they say, like, okay, how much time do I need to wait for you to start participating in the market? Because we cannot say, okay, we will just 100 kilowatts.
You need to have the data. You need to learn their profile in order to understand how they can participate.
Yes, but then like we have like an assumption. Let's say like that the users of this, like, because it's, let's say it's not industrial. It's like EV chargers from people's home. Do we think these customers, they're like similar in a way, or like are they different actually, or can we train like some core model in this case, where it's maybe like will be deep learning model when we have like much more data, much more inputs in this case, and then maybe we fine tune it in this case. Or maybe, okay, we have a new customer. Can we utilize this master model with as little possible data that we have right now? But our goal is to reduce time to market, to market in this case. So, and I'm like, maybe I'm boring, old schoolish. I'm trying, baselines first, simple models next, and then, try to make things complicated. So what we spend maybe the first year, like at Fever, is more like, okay, we want to have data in shape and like ready at any point of time, because if new algorithm pops up, because like Google recently announced that they will have, like in GCP, they will have a service for time series forecast. If this works better than whatever we did at Fever, like why should we wait? We should have data prepared for this.
So in a sense now, you need to think about optimizing the data, but actually the more you're collecting data and having it in a good quality setup, you can actually feed that into new technology when it comes.
Absolutely. And then this
is smart.
Yes. So the thing is following, because when I was working at Spotify, there was like at the beginning when I joined, like CTO of Spotify said there will be no R&D department. We want all departments being R&D departments. After some time, there was R&D department, and these people were doing like a lot of things. And then suddenly OpenAI publishing their tool where can Spotify suddenly convert podcasts into different languages. And then you're asking, okay, we had this R&D department. They probably were doing some useful thing, but then this small startup did something like incredible. And suddenly years of our work kind of like useless, but we have data ready.
We have data ready.
And then we can convert it to maybe, something better.
So the bottom line, the research and collecting the data and working on that problem made them ready to now jump on the train much faster.
Absolutely. And then we're trying, because our big data is actually small data.
Yeah.
So we're trying the same. So we want to have like data in a good shape, accessible to anyone at the company, that because it's kind of the same as the early days of Spotify. We believe like anyone can do something with the data if they want to do something. So, and I always get like a little bit shy when people say, okay, what algorithm you're doing? And then they probably say, yeah, we're using this version 4 neural network from this crazy paper. I'm happy we're not. I'm happy we're like delivering results at this point, and we're learning market.
Yeah, but I heard, back to Pontus Wallin, who is working with data analytics in TSO. I mean, like when we're talking about national security class data and stuff like that, he pointed out the explainability is so important in what we are doing. So it actually, it's not really good practice to use too sophisticated stuff we don't really know what it's doing. So I mean, like, so he was almost arguing like, well, deep learning when it becomes more black box is kind of difficult. Do you agree with that, or?
Yeah, but I think at this point of time, like the law of big data kicks in. If something works, do you actually care why it works?
Yeah.
So like, I mean, I don't want to say this about energy.
No, but it's a tricky point. When we have music, right? I would say the law is real.
Yes.
When it's energy, and when it's this national infrastructure, sensitive stuff.
Right.
I guess you're right, but then your threshold,
Absolutely.
it's not the same game.
Yes, for us for now is actually we are like what I love about Fever. We're constantly in a learning mode.
Yeah.
So and then
cool.
And actually we are trying to understand. Okay, if these prices are like this, why this? Is it random? Is it because of this amount of, I don't know, wind? Is it because of this how like hydro plant is not working this day? So why did this happen? The same thing is about actually electrical vehicles.
Right.
We have a colleague, Daniel, who has a car, and he educated me a lot how he uses car. And actually, I think he might qualify as an average EV user.
Yeah.
So, and he told me a lot about how he thinks about car. So, and I mean, like, obviously, like, if something works, we don't understand why. At some point of time, we can be fine with it. At some point, like, I guess in the future, we should say, yeah, actually, it was bad that we didn't understand because we need to learn this now.
Yeah.
And we are now, I believe, like, starting simple but already good enough, like to attract customers and say, okay, like this is our performance, and then you can compare it to like with other companies. So we're like, from my point of view, I'm happy where we are now, and then I think we have like a good foundation for the future, which is important, I believe. As you said, like with all the advancements of LLMs and everything. So I think we just should be ready for like what comes next.
Yeah. If I can just add, I think you're completely right in that it can't be too black box right now, because we're also on a kind of journey together with the TSOs.
Yeah.
To help them understand and like build confidence in what we're doing.
Yeah.
Because they're not used to this.
Yeah.
And so if we can't explain how we're doing things, they will never trust us to kind of handle parts of the critical infrastructure.
Yeah, so this is also part of the maturity game in terms of the whole society and our decision makers. And this needs to be done stepwise.
Yes.
Yeah. I mean, like there is another angle to the same question, and that is a little bit to, instead of looking at the engineering problem, what's the data problem? What's the data? How is data collection? What is the challenges of collecting data in this ecosystem? What is that all about?
Since so far we're not participating in like real-time trading, so for us it's more or less like there are things like, okay, what were the different type of prices? What was like the energy export in different parts of Sweden, like in Scandinavia, like all of it. And other things is like, okay, how our batteries are behaving. So like our batteries actually provide to us like a lot of data. The same thing comes to electrical vehicles.
Yeah, so let's sort me out here. Like, so we put the battery. Let's see if this is one of them more like I would put at home. So then you connect the battery and you set it up so it sits sort of close to your main box.
Fuse box,
right? And then it needs to be connected. What is the data you are then measuring and looking at? You need to get the feeling for the profile of that house, right? How is it used, or what is the data there? Is it smart meter data kind of stuff that you're tapping into, or?
So we, at times we look at the household data.
Yeah.
Kind of to observe.
Not on the inside, on sort of.
Like for the full household.
Yeah.
But for us, we use that to set constraints on how different assets can be used.
Mm-hmm.
So for a battery, if there's a constraint being the fuse box, the fuse size of that household, we need to know at what times that fuse is also being kind of loaded by other consumption, or if there's production in the house, meaning solar panels.
Yeah. So this is the household part of the data collection, and then you talked about the battery itself. What type of is that? How the battery is behaving?
Absolutely. So like since we have like different types of batteries, so it's more like the most critical data is more like how battery reacts to our commands.
Okay.
So like if we ask like battery to discharge certain amount like power or something, so how fast we were like to receive this signal, because it's crucial for our qualifications and performing, and like how like so like reaction to our commands is like the most crucial data, but it's also like in the real time saying like, okay, are you functioning? So like is there like some heartbeat to the battery? So because disturbance, no one tells you in advance that disturbance will come. No. So basically like we assume that everyone should be ready, and then there can be a lot of problems because like home internet is not stable. Maybe it's like in a garage, like away from Wi-Fi. Like, I don't know, maybe Wi-Fi doesn't work today. So things like this.
So and the data, it could be everything from the state of charge of a battery, and if they're different battery cells, have they drifted?
Yeah.
New battery technology tends to drift a lot in terms of state of charge, depending on if it's warm or cold where you have this battery. Sometimes the bottom sections of a battery are colder because it's in a garage, and that screws with the entire performance of a battery. So we do a lot of testing to understand the dynamics of the longevity of a
So this is monitoring data. Is this real time? Is this like sent in batches in minutes, or how much do you ping your battery on these topics?
I guess like we have batteries that send us at least 10 seconds or 10 messages per second.
Yeah.
So this like some type of batteries. Another one maybe we don't want to talk with them that often. So then like charger manufacturers, they also kind of, because most of the, so there are different technologies, but there are technologies when messages from EV chargers go to charger manufacturer cloud. So they also don't want to maybe to send them often. So and this data we use more like for like not for machine learning, but more like for like data analytics analysis. Okay, how chargers behave, how batteries behave, how we can improve our future algorithms when we control the fleet of batteries.
And what is the data collection or data sending in the other end, sort of towards the TSO? Because if you have a balancing service, you need they are sending signals. And what is the data transfer on this side?
So actually, do you have your phone on you?
Yeah.
Okay, so I'll show you what happens. So turn on the slow-mo video.
Slow-mo video.
Yes. And let's see if we have these type of lights. I don't know if these lights work, but hold it up to towards the light.
So I should basically.
Does it flicker?
You're talking about the flicker and the frequency.
Yes.
Yeah.
So anybody can do this, I guess.
Yeah. I can't see it. Oh, I see it over there. It's flickering. Yeah, yes.
So the flickering is actually the frequency of the grid.
Yeah, the 50 hertz.
The 50 hertz. So the 50 hertz is what we have in Europe.
Yep.
And that is, if it's exactly at 50 hertz, the grid is in balance. So you have as much production and consumption at the same time.
Yeah.
So if you're very, very good at measuring the frequency of the grid, we have pretty expensive hardware distributed all over Sweden.
Mm-hmm.
We can listen to the exact balance of the grid. If it dips below 50, more energy is needed.
So Fever is doing this?
Yes.
So Fever in your negotiation and partnership with TSO, you are one of the key data collection point is to listening to the frequency of the grid.
Yes.
In strategic places.
Yes.
As a way to signal actions or.
But and here's the fun part.
Yeah.
We have the exact same frequency if you plug it into a socket here, as if somebody plugs it into a socket in Oslo.
Yeah.
So we just need expensive equipment to measure this frequency, and we read it many, many, many times a second.
Yeah.
Because then we have a perfect state of what the grid needs from us.
Yeah.
So the TSO in this product, they don't actually have to tell us anything.
No.
Because it's kind of built into the grid.
Because it's built into the grid, but what then is happening is that you're listening, converting that into an analysis and ultimately an action.
Yes.
So basically, this is happening then in real time.
Yeah.
So in real time, like in microbursts, get more energy from this guy, get more energy from that guy, stop using that one. And so this is, and what are these algorithms that sort of, this is then balancing what is happening here, like what is that? Because then there's a lot of signals coming in, you're listening at a very, very high frequency, and then it should execute according to that.
Yes, when it comes to algorithm, in this case, it's kind of like home-cooked algorithm, especially when it comes to EVs. With batteries, it's like a little bit simple. Like if you have like industrial-sized battery, it's like some of them have meters inside them, so they can do everything on their own. If they not, then we need to send them a command, basically.
Yeah.
So you can think about it as, okay, like if the frequency is very, very low, you need to operate 100%.
Yep.
If it's not that low, maybe 50. And then if it's not reached, like then 0. So basically you convert frequency and your amount of energy you promised to TSO to how much battery should charge or discharge right now. The same goes to our electrical vehicles. So how it works, we're listening to the signal, okay, we detect disturbance, it's called what it's called. And then we know, okay, how severe is disturbance?
Mm-hmm.
Okay, it's maybe that severe, like this, like 20% of what we promised. Then we pick chargers, send commands, wait. While we're waiting, frequency may change to better or to worse.
Mm-hmm.
And then we need kind of like say, okay, this was our previous state, we're now in a new state. How do we tackle this new state in a way?
Yeah.
So like, do we stop more chargers or do we cancel maybe some commands if it's possible still? So that's and that's, as you said, like it happens like, I don't know, 10, 20 times per second.
But so would you say, I would reflect over this, like this is the real mathematical engine of everything, which is part of the core of what the Fever optimization is doing? Or is this proprietary? Is it you that have cooked that up, or is it something that you can buy, or this is work in progress, I guess, or how is it?
I would say word mathematical might be true, like just part of it.
Yeah.
And I'm not sure if you can buy it. So it's actually what we're selling in a sense. We say, okay, we got some like experiments, we got some data, we got some experience with it. Like
But you need to code it in such a way that it actually works.
yes, but it's also like in terms of software,
Yeah.
so it's reliable and
Yes.
it's fast, but
Yeah.
it's also like if we, as I said, like if we stop too many chargers, what do we do when it's actually
because
became
this
worse?
is becomes this is when it, what is the AI, what is the software? It's a system, and you need to optimize for unreliability, you need to optimize for latency and speed, you need to optimize for executing commands, and then in here of all this, what is software, what is data processing, what is algorithm, it's a system. This is how I would summarize it.
Very perceptive of you.
I think if it just may, so like the full cycle, I think when it comes like to software, like AI engineering at Fever,
Yeah.
when you get flexibility asset, you need to prove to SVCO or to TSO
Yeah.
that this asset is actually can be qualified to
Yes.
participate in this market. And then you need to write certain type of tests, which also involves like, engineering skills. It involves mathematical skills, because like there is something called the Nyquist diagram that we need to plot, which involves like complex numbers, and then anyone can say, okay, this should be provided, but we coded it ourselves because at the beginning it wasn't really working for us. So SVCO provided as like Windows tool to build it, and it didn't work for us, unfortunately.
So you need to build a tool as well.
Exactly. We implemented my colleagues implemented it on their own. So, and this is a whole cycle. You run test, and then you fill the document, right? Like Jonatan has PhD in filling SVCO
documents.
Yes. And then you send it, you wait, and then you are like, okay, I'm approved work for this. What happens next? We take this asset with its like power, we go to a bidding market.
Yeah.
So then we predict, okay, what was like should be our price, and then like if it's battery, we know the capacity. If it's electrical vehicle chargers fleet, we need to predict capacity. So there is like already starting, some machine learning, which is maybe not related to this specific device when it comes to prices.
But this is an ecosystem. I think one of the main points that I want to make with a conversation like this for anyone listening, you cannot start putting machine learning engineers over here and data guys over there, and then this is a cross-functional team working with a very strong system or product mindset. Would that be a fair summary? That don't even try this at home, girls and boys, if you're not willing to work together as a team on this? Because I see this over and over again. Here's the AI guys, and here's the machine, and this is typical the analog company who they are not the software company, so they haven't figured this out yet.
Absolutely. I mean, there is like certain things that, like you cannot say I am backend engineer and then I cannot do anything else.
Exactly.
Or like say, okay, I can build this model, but you use this model. No, we're kind of like we're all working together. So like when we participated in the market, when we did our predictions, then it comes to execution part. This is pure software engineering part, but it's also we want to have best strategies. Maybe we can learn these strategies from our previous experiments and from the data and all of it. So like it's a full pipeline where
And you're multidisciplinary teams. You're working as one entity, but you're T-shaped. You understand the problem of the grid, but you have your own super strengths in this team, and then you try to solve whatever comes in front of you.
Yes. I think like one thing I'm feeling sad a little bit because we're becoming bigger. We have like more people, and then before I could write code in any part of the company. Now I'm already I cannot.
So this is
I
the
cannot
interesting
focus,
part, right? Yeah.
I cannot focus on everything right now. So sometimes when people are solving problem, I'm like, like really want to solve it, but I mean I need it probably. I will have better input in another place.
Yeah. Wow. All right. There's so much to talk about. We're already going for 2 hours, and but I think we should wrap up with a couple of little bit more like bigger questions. I think one macro question or geopolitical question. Yes, I think it's a geopolitical question that I think you guys should be maybe closer to than others. Is this whole topic of cybersecurity. And where we're thinking about the world, and where we're thinking about this, because I think typically infrastructure like the grid is one of the key stuff you want to protect on a national level. And cybersecurity strategies or cyber war, of course, has infrastructure attacks as one of the main vectors. So what is your thinking, and how do you discuss and think about cybersecurity at Fever, and how do you try to be resilient, or what is the cybersecurity conversation going on at Fever?
I mean, I would say it started from day one. We know this is critical infrastructure.
Yeah.
Even kind of our investors have to go through pretty rigorous security processes. So going back to what you said around building a system, this is a core part of how we built it. Not only stability, but redundancy, very high security. Because if we do our jobs well, we're going to be a critical part of this ecosystem. And we need to do it in a way where we're not the first attack vector, at least.
Yeah, so I can imagine like being part of the infrastructure, like a grid. That you need to have a strategy for not being hacked or being able to combat hacking, and that is one of the fastest moving technology trajectories. Like there's no new patches, So how do you deal with sort of having your cybersecurity software division being one step ahead? How does that work?
Like in a simple case, we have like we have a colleague of ours whose responsibility is like this part. So he educates us about a lot of things. He has experience, like he has hardcore security experience from his previous works. So we're like not only employ like the best practices of like just basic things like changing passwords, like encrypting everything. So how we work with clouds, how we work with our devices, and all of it. So this is even out of the question. This is solved.
This is hygiene. This is solved.
Yes. Yeah. So
but I'm more about how to stay, because this is a continuous operating model is a continuous improvement.
So I'm not in the kind of tech coding, obviously, but I think one thing that we speak a lot about is keeping things simple and nimble, and not making kind of our product and tech too big unnecessarily, because that just increases the chances of slipping up. So that's just one thing I kind of observe from kind of across the table.
Yeah, because I think the security then becomes an architectural strategy as well. Like you have that as a core framing requirement in everything you do. So you take choices. We don't want to do it like that because then the blast radius is too big. We'd rather do it like this, containment and all this.
Yes, and we're trying like to also like to separate our like services. So let's say like if for some reason our like electrical vehicle for this customer is down, doesn't mean that like all customers like should receive the same experience in the way, or like if the battery service like that controlling this certain battery is down, shouldn't influence all our assets at Fever. So things like this.
Yeah,
it's just like very simple approaches that actually saying that okay, there shouldn't be like single point of failure in this case.
Yeah.
It's not a coincidence that kind of the core backend team comes from fintech, autonomous vehicles, Volvo M.
Yeah. Because all of them has in different ways high safety standards, so have to have high safety standards in different ways.
Yeah.
But where do you think the whole cybersecurity or cyber threat? What's the trajectory on that? Are you anticipating changes even now with the LLMs or different attack vectors coming in, different ways of doing it? How are you seeing cybersecurity topic evolving?
So our going tips now to fail Swedish grid. 5 tips to fail Swedish grid. No,
5 tips.
No. So what I wanted to say that it's like I think the main point about like the future and everything. So is that there will be a lot of companies and a lot of distributed assets. So it will not be possible to say okay, if we're killing this point of a grid, or if we're killing this hydro plant or like whatever plant, that doesn't mean that Swedish people in different parts of Sweden will stop receiving electricity. It might be a case now, but shouldn't be a case in the future. So future of the grid is distributed. So if one part is not functioning, another one is for sure should be functioning.
So it really means that if we build this right and the distributed world with a high security topic, we will minimize blast radiuses of any attacks or any problems. This is one benefit of a distributed architecture, I guess.
Absolutely. And then having small distributed assets will have some neighborhoods for some time when things are getting fixed. So there will be no problems with hospitals or something.
Yeah, but the counter argument to that is, of course, that there will be a lot of backdoors now. Can you? I mean, with the distribution, you have more attack vectors, and with more attack vectors, potentially this is where you get the worm in to send. So there's two different ways of looking at distributed risk.
I think the new world brings electricity and kind of information much more closer. So if you have a data center that goes down, that could also mean that parts of the electrical grid goes down. Yeah. So you have a different type of coupling.
Yeah, this becomes a new type of coupling and a new type of cybersecurity context.
Yeah.
So go there a little bit now, because now we're getting back into what is the AI divide and what is the electricity divide and what is the convergence between information and electricity. So I think your starting point was quite interesting. But we are circling around information, AI, electricity, and how this is converging in different ways.
I can absolutely say that there will be there will be probability of something bad happening. So there were we already saw some incidents in Finland where some software was giving some very low numbers on the market. So for some time, and in Finnish grid, you will get 5,000 euros, if I'm not mistaken, per hour if you consume an energy, 5,000 euros because of software issue. So this we will absolutely have problems with it. So the question is, okay, I think SVK, its role as a TSO will be in the future. Okay, how we invite more people and make sure that even if one of the actors is not functioning, how to make sure we still have grid in a good shape.
I don't know. Yeah, I think my answer is I'm not educated enough to kind of talk about the new state of cybersecurity.
Yeah.
So I think
we can back out of the cybersecurity topic. I'm going to test an hypothesis on you, where I think that there needs to be a wake-up call in companies like SVK. Because if you have the understanding of convergence between software algorithms and hardcore energy and energy grids, you kind of need to have a team, an organization, an operating model that reflects that. So if you have an organization where we sort of have the hardcore craft, power engineers over here, with their view, you told about the two cabs, and then you have new guys who are more distributed. I'm just going to add now to you, you know what? SVK needs to be 50% software company as much as they are an electricity company. So I saw this already in Vattenfall, and I'm like, you don't get it, right? You think you're a big asset operator, but in a distributed world where information and software is going to be so big part of the game, and we have just now proven that you can't do shit if you're not putting a cross-functional team together, I'm a little bit worried about, you know what, have you woken up that you're a 50% software company, and then 50% AI company, and then 50% electricity company? So you're a 150% company right now. It's a joke, right? But I think I'm a little bit worried. Do they understand themselves as a software company?
They kind of become the sum of all the parts in the system. And if parts in the system are...
How will you manage the national grid if you are not understanding what it is you're managing?
Yeah. Okay,
and if part of your management is copper, another part is software, and a third part is algorithms, what the fuck are you managing if you're leaving 2/3 of the problem at the table? I don't get it.
Yeah. It's
this is a provocative question, but I think we're talking about the Swedish infrastructure here, and where they're only doing 1/3 of their job.
I have two answers. Maybe first one, when we're selling, what I said about this qualification process, when we're sending this qualification, sometimes we get amazing questions back about our software, which kind of when when you talk,
they know what they're doing.
yeah, when you talk to someone and someone asks right questions, you're like, okay, so you probably know what you're doing.
Yeah.
And when they ask these questions, I'm like, wow, I'm actually feel a little bit more positive, because, you know, you rarely can say this when it comes to software and government company.
Oh.
This is the first thing. And the second thing, I think Anders is an amazing example of a person working in the government organization who worked before
Yeah.
in the companies where which, you know, have high software standards.
Yes.
So I hope actually when companies in Stockholm were laying off people, I was thinking, oh, maybe finally companies like SVK or like Migrationsverket or Skatteverket, they will finally get like talent that they deserve.
Yes.
Meaning deserve like that, like, you know, in my perfect world, smart people should not only solve like the problems of how they sell ads, but also like, you know, doing some, things that help countries where they live.
Yeah, but because I don't want to bash in any way like this, but I think this is it's the analog companies of the world that all of a sudden is growing into a new type of role. So at Proud Analog History, and they've done an amazing job, and they now need to pivot to something that, you know, no one knows exactly how this is going to look like, but it's an interesting challenge, and I'm very humble to it. So I'm just saying, I just hope the right people are waking up to it in time. It's good to hear and reassuring when you get good questions back that I know there's so much good talent in software and AI over there. I just don't think it's enough. I think you need more.
I think you're right. I'm just happy that, you know, there's something pushing back to the Klondike moment here. Also, that we also need to think about how do we explain what we're doing and be mature and to avoid too many cowboys.
Yeah, but maybe that's a good ending note, because I think we are running over time now, because another way to become a software company for a company that has a proud analog history is, of course, to partner with startups and partner with companies like Fever to solve the game together. And I think that's why I'm so happy to have you on the pod today. And, you know, because I think that's actually the fastest way they can solve that major talent issue they would have otherwise. So I think you're doing a great job, guys.
Thank you.
Thank you. And thank you for inviting. And I'm a little bit sorry that we didn't discuss hiring.
Yeah.
maybe part two.
Yeah, maybe part two. I was getting to it, but never got to it. Okay. Thank you very much, guys.
Thank you.
Thank you.
Thank you.